first thing we're going to do is just review. So this should all be stuff that maybe you've heard before, maybe it like rings a little bit of a bell, or maybe you remember it all and you're like, this is really boring. We're going to start off with definitions. So we're going to talk about polynomials. That's what this unit's called. We'll start off. Oh my goodness, it's not working. It doesn't like me. Try that again. There we go. Let's do a little bit more. This unit is called polynomials. It's got letters in it, right? So the last unit was all numbers. Now we have letters involved, so you're going to start seeing things like 2x and stuff like that again. Remember, a technical term for letter is a variable. Okay, so when we talk about letters, I'm going to call them variables. I typically still call them letters, but just so you know, we will have variables in this stuff. For something to be an algebraic expression, it means it doesn't have an equal sign. So something like this. There's no equal sign, so I would call that an expression. I don't use that terminology very well, but it is the technical definition. Once there's an equal sign, it becomes an equation. Right? The biggest thing I want you to kind of pull out of this is some special polynomials that we'll talk about. The first one being a monomial. Now, a monomial is a polynomial that doesn't have an addition or subtraction. So if you look, these are all monomial expressions. The reason being is that they don't have any pluses or minuses, right? It's just 6. It's just x. It's just 6x. There's not 6 plus x, 6 minus x, or anything like that. We will have to make decisions on negatives versus minus signs. So if you look at this guy right here, this is still monomial because that is a negative sign in our eyes, right? If it's the leading thing, the very first thing, we would call it a negative sign. It's a minus sign if it's separating two things. And that's kind of how we see the difference. Even as you keep going, there's some complex ones here. So 2p to the power 4, q to the power 2. That's still called a monomial because there's no additions or subtractions in there. Nothing's separating it out. Awesome. As we start adding additions and subtractions, we create different polynomials. So if you look, these things are all examples of polynomials. 6 plus x, 2y plus 7z, x squared minus 5x minus 9. Those are all polynomials, just examples of polynomials. There's special polynomials, so ones that have special names. And polynomial means many terms. Many nomial terms. So it could be ranged from one term to a gajillion terms. The ones we focus on have special names. Monomial was one of them. Binomial is the next one. A binomial would have 2 terms. Okay. Binomial. 2 terms means you have 1 plus or minus sign. This is 2 terms. X plus 4. Right? X is 1 term, plus 4 is the second term. If you had 3 terms, you would call it a trinomial. So looking at this one, this is a trinomial. X squared is 1 term, plus x is another term, plus 4 is another term. It is a trinomial. But anything else, we just call polynomial. So if there was another plus x to the power 3 or plus q, we just call that a polynomial. There's nothing special past that. These are the ones we work with the most, not exclusively, but the most. All right, so you'll hear me very often say, like, you have a trinomial, you need to get a binomial. You have a binomial, you need to get a monomial, like things like that. Okay, so these are the ones I'll definitely reference the most. Does that kind of ring a bell from last year? So like, yeah, a little bit, yeah, variables, we kind of get it. All right, we're just going to say if things are monomials, binomials, or trinomials. Okay. See whether the expressions are polynomial or not. If the expression does not represent a polynomial, explain why. If the expression does represent a polynomial, state whether the polynomial is monomial, binomial, or trinomial. It's a lot. So let's look at this first one. Looking at this question, that would be a polynomial. Okay. Things aren't polynomials when weird things happen, like negative exponents and stuff like that. I'll show you a couple examples. Basically, everything we work with will be a polynomial. What I really want to stress is the type of polynomial you have here. Right? This is 1 term minus this is my second term, creating a binomial. because that thing has two terms. Awesome. If you look at the second one, we would say that this thing is not a polynomial. The reason why is because something weird is going on. If you look at the exponent of one of the variables, you have an exponent of 1/2. Right? Because of that, you're not allowed to have decimal exponents, negative exponents, or fraction exponents. Okay? That means this thing is not a polynomial. And at the end of the day, we rarely work with that stuff. So you shouldn't stress it too much. Awesome. If you look at C, C is a polynomial because all the exponents are normal, right? X to the power 4, X to the power 3. That's good. How many terms are there? 3. Yeah, there's 3, right? So if you're looking, this is one term, minus this is a second term, plus this is a third term. That's 3. That's a trinomial. Awesome. You look at D, that thing is not a polynomial. Reason being is you have this 0.2 right there. And we're not allowed to have fraction or decimal exponents on the variables. The very last one is a tricky non-polynomial. The reason it's tricky is the exponent on the A looks like a 1, right? So it looks normal. But we actually know that this thing is 7a to the negative 1. Right? If we think about our exponent laws from before, we know it could be rewritten like that. We're not allowed negative exponents. That's the technical reason why. An easy cheat for you to be like, well, how do I know if it's a negative exponent or not? You're not allowed to have variables on the bottom. Okay? If you have a variable on the bottom, it's not a polynomial. Again, we almost exclusively only deal with polynomials, so I wouldn't stress too much about that stuff. The stuff I really would want you to focus on is monomial, binomial, trinomial, and knowing which one's which. Awesome. I need to do the first one with you, because we're just going to go through a couple definitions one more time, and then I'm going to let you try to fill out this chart on your own. So, this says, this is all your polynomial expressions down in this column. We're going to take each column and fill out the info about it. So we have 3x plus 3yz. The first column says number of variables. Variables being letters. Okay? And it means number of different letters. So for instance, if you have x squared plus x minus 2x cubed, that would be one variable because it was just the letter x. In this case, we had 3 different letters. That means we have 3 variables in this question. There's x, there's y, there's z. Number of terms. Terms are things that are separated by additions and subtractions. If you look, this part is one term, plus that's the second term. Anytime you have a plus or a minus, it's separating terms. This thing has 2 terms. Because it has 2 terms, we call it a binomial. I will let you wonderful people try to fill out that chart quickly, and then I will fill it out with you so you can see the proper answer. This first or second one, it's the number of variables. Okay, there's an A, a B, a C. That's 3 different variables. There would be 3 for the first column. Number of terms. Looking at this thing, 1 term minus another term plus another term means 3 terms, means trinomial. Awesome. Looking at this guy, you have x squared plus 3x plus 4. That would be 1 variable. Right? There's 2 different x's here. There's the x squared and the x, but it's the same letter, so it counts as 1 variable. Number of terms would be 3. X squared is its own term, 3x, and then 4. That'd be another trinomial. Fourth one. There's no additions or subtraction signs. Oh, I got ahead of myself. Number of variables. There's only one variable there, x. Now, we're talking about the number of terms. There's only one term here because there's no addition or subtraction signs. Okay, so that is the full term, meaning one term, meaning it's a monomial. Last guy, we look at that thing, number of variables. There's an x, there's a y, that's it. So there's two. Number of terms, we have one term plus another term plus another term minus another term. That's 4. We don't have any cool names for anything above 3. We just call it polynomial. All right, so if it's not one of the 3 things we know, it's just a polynomial. Awesome. Another definition that we use that I should use more of is called a degree. The word degree means highest exponent. It says that lower, but I suppose here. And so if I say, what's the degree of that polynomial, what I'm saying is, what's the highest exponent of that polynomial? Like, for instance, looking at this right here, that would be degree 5, because the highest exponent is a 5. If I looked at the next one, I said, this weird-looking thing has degree 3, because 3 is the highest exponent that we see there. Awesome. Looking at this guy. We want to know the degree of that polynomial. The highest exponent of that polynomial would be a 4. And it happens to have 2 4s, right? It's y to the power 4 and x to the power 4. Beautiful. Another definition, constant term. So a constant term is something that has no variable. No letter multiplied to it. So if you look at a question like this, and I said, what's the constant term? That's asking you which term has no letter to it. This term has no letter to it. It's just -2. There's no x, there's no y, just -2. So the constant term is -2. Beautiful. Let's try to build a couple of these things. So we're going to give an example of a binomial of degree 1 in one variable. Binomial means 2 terms. Degree 1. That means highest exponent is a 1 with one variable. So if we want to do an example of this, you could go something like this. 2x plus 3. That is a binomial. It has 2 terms. The highest exponent is a 1, degree 1. And there's only one variable, right? The letter x. Beautiful. There's infinite answers to this question, right? That's just one of many examples you could give. As long as you have a plus minus symbol, that created 2 terms, which is a binomial. As long as your highest exponent is a 1, and you didn't have anything other than just one singular letter. Awesome. Part B, a trinomial. Trinomial means we need 3 terms with 2 variables, that's 2 different letters, with a constant term. That means you need at least one thing that has no letters attached to it. So if we were to do this, 3 terms, 2 variables, I could do something like 2x plus 3y. Then I need a constant plus 5. That would fit everything I want here. Trinomial, 3 terms, 2 variables, x and y, constant term, plus 5. Part C, a monomial of degree 6 with a coefficient of 9. Coefficient is the term we used last unit. So a coefficient of 9, I mean, you have a number in front of a variable of 9. Okay? Monomial means you only have one term. Degree 6 means the highest exponent is 6. So if we looked at something like this, I would say coefficient of 9, x power of 6, to give me a degree 6. Last one, a binomial of degree 8 with each term containing 2 variables. All right, binomial means I have something separating 2 terms. Degree 8 means one of them is to the power of 8, I do x to the power of 8. Each term contains 2 variables. So this needs to be x to the power of 8 times some other variable. The other term also has to have an x and a y. Right? 2 variables to it. That's a binomial of degree 8 with each term containing 2 variables. Fantastic. We don't stress this too much, so I'm going to do it pretty quick. Writing things in, oh, sorry, look at that, I almost skipped something important. One more definition that really matters to me. Leading coefficient, that's one that's important to me. Okay, a leading coefficient means it's the coefficient in front of the variable with the highest exponent. Okay, so for instance, if you were to look back at examples we've done, let's just peek up here. The highest exponent in this question was x squared. The leading coefficient is the number that's right in front of it, which would be a 1. You look at this question, the highest exponent that I see is x cubed. Leading coefficient is the coefficient of the highest exponent, it'd be 2. Right? That's what a leading coefficient is. The best way to kind of figure out your leading coefficient is to write your polynomials with the highest exponent first. All right, so for instance, and we call it, that's descending powers. Right? So it says write as a descending power. That means highest exponent first, then go down from there. Looking at this question, the term with the highest exponent is this guy right here. That means I would write it as negative 4x to the power of 3. The next highest exponent would be this guy right here. So I go plus 6x squared divided by 5. The next highest exponent that we see is right here. So we go plus 2x. And that leaves us with our last one, which is, let's see if I get a good color here, the negative 7. That thing is written in descending powers, highest exponent to the lowest exponent. That's the best way to write things for several reasons. One of the biggest things is it makes figuring out your leading coefficient and your constant really easy. All right, your leading coefficient is the number in front of the highest exponent. If you look, x cubed is the highest exponent. That means negative 4 is my leading coefficient. The other thing it makes really easy to pick out is your constant term. Because if you do it in a descending order, your constant term will always be the last thing. So that's my constant term at the end. So when you get questions, it might help to write them in descending order. They typically already are, which is kind of nice. But if they're not, maybe you want to flip it around a little bit so it's easier for you to see those two things. Awesome. I'm going to keep going. It's just to do some questions. But we're not going to do the algebra tiles. We're going to skip that. If you remember algebra tiles, you are more than welcome to look at that and read about it and think about it. We'll maybe chat about it another day. But today, all I want to do is get to adding and subtracting polynomials. Perfect. Adding and subtracting polynomials. This should be reviewed to you as well. So when you add and subtract polynomials, we talk about something called like terms. And this word right here, like terms. Okay. Like terms means that they're the same variable with the same exponent. So for instance, x's with other x's are like terms. But an x and an x to the power of 2 are not a like term. Okay, because it has to be the same letter, same exponent. I always say like letters go with letters, right? So same letters go with same letters. Numbers go with numbers. Constants go with constants. I think that's kind of the phrases I will use. Letters go with letters. If you look, they give you an example. These are all like terms because they're all the same letter with the same exponent. They're all a to the power of 1. These guys also all like terms because they all have the same exponent with the same letter. It's all x to the power of 3. These guys are not like terms. They're all x's and that's great, but they all have different exponents. Awesome. These things are definitely not like terms because they're different letters. Right? X's and Y's don't go together. Adding and subtracting like terms. Do one question, 2 questions? Yeah, I'll do 2 questions. And I'll let you guys check. I like to kind of underline my like terms. Okay, I'll use different types of lines, like a wavy line and a straight line. I've seen some people do shapes. Right, they'll do like a triangle for like terms, a dot for like terms, to try to stick out to them which ones are like terms. This is how I do it. So if I look at a big question like this is a trinomial plus another trinomial. I look at my A's first, and I'm going to underline them with like these little waves. Okay, I have 3A and a minus 3A. The way I like to think about this is that A means something. To me, typically food. So I would say like cookies. So this would be 3 cookies minus 3 cookies would leave me with 0 cookies, right? There'd be none left. You guys probably heard that they cancel out. Right? It's like, well, if you have 3A minus 3A, they cancel out and you're left with nothing. But in reality, it's because you lost all of whatever those things were. To me, almost always cookies. The next letter I would look at would be this one right here. I look at B. I underline all my other B's. Okay, so I have negative 4B plus 3B. Again, I think of this as things. So if I have negative 4 cookies and I add 3 cookies, I have a total of negative 1 cookies. Okay, so the B is still there because the B represents the thing that you're adding or subtracting. The number in front represents how many of those you have. My last one is going to be C. So I have plus C minus 5C. Again, think of it as a thing. So if I have plus 1 of something, and there's an invisible one there, and then subtract 5 of those things, I would be left with negative 4 of those things. Negative 1B minus 4C would be that polynomial with like terms collected together. Awesome. Every once in a while you'll see something like this. We see this more later on, one of our last units, where they add and subtract the polynomials, but they write them on top of each other. Okay, this one is done with a subtraction sign. So what this question means is you take all your like terms, so 4x squared minus 2x squared. And so if you have 4 of something and you subtract 2 of something, you're left with 2 of those somethings. Then you're going to move on to the next one. You have negative 9x minus negative 3x. If you're unsure on your negatives, use your calculator to do that question. Don't put the letter x into your calculator. Just do the coefficients. So go negative 9 minus negative 3. And your calculator would tell you that gives you negative 6. And you would still have x, because that represents the number of things you have, or the thing that you have. Last one, I've got 6 minus negative 1. Again, put that in your calculator. You'll come up with a positive 7. Beautiful. So when you're adding and subtracting like terms, you're looking for same letter, same variable, and you're just dealing with the coefficients, the numbers in front, right? That's what you're adding and subtracting. The x's and stuff like that, they just stay the same all the way through. There's 2 questions here. See if you can collect the like terms. They're a little tricky, okay? And I'll do it with you. So if you get stuck, that's okay, because these are tricky. We haven't seen them before. But give it a shot, just to see if you're graphing. And we try to add and subtract like terms. The second one's crazy. The first one's a little crazy, but it's not that bad. Looking at it, I'm going to start with just whichever one's first, which is the letter x with an exponent 1. So I'm going to look at this and underline any other x's with exponent 1. This is the only other one I have. Okay? What these two will represent is 4x minus 1x. In my calculator, if I went 4 minus 1, it would tell me that it's 3 x's. The next letter that comes up is an x squared. So I'm going to look and I'm going to underline all the x squareds that I have. I have negative 2x squared minus 6x squared. I let my calculator do the work. So I go minus 2 minus 6 to get negative 8x squared. Then I'm going to look and see the next term I have. I have a plus 3. It's a constant term. There's no letter involved. My other constant terms with no letter involved would be the plus 5. If you have plus 3 plus 5, that gives you plus 8. That would be me after I've collected like terms. You could have them in a different order, and it's the same thing. Right? So if you had negative 8x squared plus 3x plus 8, that's the same thing. B is a little crazy because there's 2 letters, right? So that messes things up. When you're looking for like terms, it has to be the same letters with the same exponents. So the first term is a squared b. That means I can only combine it with other a squared b's. The other a squared b is right here. The first term, there's 1 of them, plus 5 of them gives me 6 a squared b's. Okay, try to think of it as a thing, right? A squared b is a thing. It's not going to change, just the number of them is going to change. The next term that I have is an a with a b squared. The other place I have an a with a b squared is right there. I'm going to combine the coefficients. So if I have negative 1 of them, that's what this represents, minus 7 of them, I have negative 8 total. Again, your calculator can do the work, just don't put the letter in your calculator. Put negative 1 minus 7 to get negative 8. The last term that we have is this guy right here. So 4a cubed b, there is no other of them, so it's plus 4a cubed b. And this polynomial turned into a trinomial once you collected like terms. When deciding on the type of polynomial that you have, you should always combine your like terms first, then say, okay, this is a trinomial. Awesome. There's a bunch of practice here for you now. We will get into the next part of the unit as well.